Alright, this is lesson 84 for 7th grade, and today we're talking about algebraic terms. Obviously this is an algebra topic and it's something that might pop up on the MCAs, so we're going to cover it right now. And this will be the kind of the beginning steps of this process. We're going to be combining algebraic terms is what we're going to get to today. And we're going to find out later that being able to use this skill is going to be very helpful and make things a lot easier for us. So let's kind of see what algebraic terms are first. We have used the word term in arithmetic to refer to the numerator or denominator of a fraction. For example, we reduce a fraction to its lowest terms. In algebra, term refers to a part of an algebraic expression or equation. Polynomials are algebraic expressions that contain 1, 2, 3, or more terms. So basically polynomial means an expression with many terms. And here are some examples. Okay? The examples are on this side here. It could be as simple as something as negative 2x. That would be one term. That is called a monomial, okay? Because there's only one. Mono means one. Second example has two terms. A squared is one term, minus 4b squared is another term. Okay, that has two terms, binomial. A trinomial has three terms, and that's these three right here. 3x squared, a minus x, and a minus 4. Now we're going to find out that we can treat these like minus x as a negative x, minus 4 as a negative 4. Same thing, we can do that. Alright? It says terms are separated from one another in an expression by plus or minus signs that are not within symbols of inclusion. Alright, so a symbol of inclusion would be like parentheses, brackets, square roots, absolute value signs, things like that. Okay? So, to help us see the individual terms we have separated, we have separated the terms of the binomial and trinomial examples with slashes. So these were the ones that we saw before. A squared minus 4b squared. That was that expression. What they did is they split those up into two parts. And notice how they kept the minus sign with the 4b squared. This indicates that we have a negative 4 times b to the second power. Alright? And they did the same thing over here with the 3x squared minus x minus 4. Alright? So they split this up too into three terms. Alright? Now, every term contains a positive or negative number and may contain one or more variables. Sometimes the number is understood and not written. For instance, the understood number of a squared is plus 1, since a squared equals positive 1 times a squared. So anytime we don't see a number in front, we assume there's a 1 there, because there is. Because anything times 1 is just itself anyway. So 1 times a to the second is a to the second. So we just call it a to the second instead of putting a 1. So, again, when a term is written without a number, it is understood that the number is 1. When a term is written without a sign, it is understood that the sign is positive. So for instance, this term, there would be a 1 in front of this one that we don't see. It's also positive. Okay. The only time it's negative is if you see a minus sign in front of it. Alright. So this was what we broke down, this expression right here in this table. So we had three terms. One of them was a 3x squared, one of them was a minus x, and the other was a minus 4, or negative, whatever you want to think of. So what number is in front of each variable? Well, positive 3, minus 1, because if we don't see a number, there's a 1, right? And then this is a constant, so it's just minus 4. So that's the number that we associate with each term there. The variable, x to the second power, x, and that one doesn't have a variable. It is not necessary for a term to contain a variable. A term that does not contain a variable, like negative 4 or minus 4, is often called a constant term because its value never changes. Okay? The variables, they can change, and they can change depending on what we put in or what we're solving for. But a constant will never change. A constant will stay the same because it does not have a variable attached with it. Okay, now those constant terms that we were just talking about, they can be combined by algebraic addition. So for instance, if we have this expression, 3x plus 3 minus 1, we can turn this into 3x plus 2 by adding positive 3 and minus 1. Alright, so they took this plus, or positive 3 minus 1, or 3 minus 1 is 2. So they took an expression like this, and they turned it into something easier to work with. Alright, so that's basic addition, or basic subtraction. We can also do this with algebraic terms, and that's the whole point of today's lesson. Variable terms can also be combined by algebraic addition if they are like terms. Like terms have identical variable parts. For instance, this. So we need to look at the fact that they have identical variable parts. They have to look the same. Alright? X, y squared, or x times y to the second power. X times y to the second power, xy squared. They both have that. They are like terms. That means we can combine them. Alright? If we don't see a number, remember there's a 1 here. Now what do? Since they have like terms, we can combine them into, now we take the number out front and the number out front and we add them together. Negative 3 plus 1. Negative 3 plus 1 is negative 2. So if we combine these, we get negative 2 xy to the second. Alright? Now, some students wondered why the variable powers didn't change. When we add or subtract with like terms, exponents don't change. We'll find out tomorrow. It's when we multiply those variables, that's when the exponents change. We've seen that a little bit already. For instance, x squared y times xy. This had to the first x, or to the first power. What we could do is add our exponents, or see how many x's we have. X to the second times x to the first, add, because we have the same base. X to the third, this would be y to the second. Alright, now when we multiply or divide, that's when the exponents change. When we add or subtract, those exponents will not change. And we'll get into more of that tomorrow. Alright, so let's take a look at, I think I have 2 examples. We've got more to do tomorrow. Alright? Now the first thing we should note is we cannot solve for any of these variables. And the reason is because we don't have an equal sign. Alright? We need an equal sign. We have to have this whole thing set equal to something in order to do solving. We don't have that, so we can't do that. But we can combine the like terms and make this statement easier to work with. For instance, we can combine 3x and x. Okay? Now, this isn't what the book does, but I like to circle what I'm going to combine and bring them together with sort of an arrow. And I like to include the sign that's in front of the variable or term, because then I know what to do with it. For instance, here I have positive 3 plus an x, or we know if we don't see a number, it's 3 plus 1x, or 3x plus 1x, which is a 4x. We can also combine y's. They are the same type of variable. We have plus 1 and a minus 1. And if we do that, we get positive 1 plus a negative 1, that's just 0. And normally, or what happens here is we are adding, so adding in between terms. 4x plus 0, well that's just going to be 4x. And that would be our answer. It's a much more simplified version of what they gave us at first. And we'll find out later on in algebra, we'd much rather work with 4x than this crazy looking expression. So that's kind of what we're doing there. Let's take a look at the next one. Collect the like terms in this algebraic expression. Once again, we can't solve for anything. It's not set equal to anything. But notice it doesn't tell us to solve for anything either. Okay. So first of all, let's take a look at 3x. Remember, they have to have identical variable parts. So x to the second and x are completely different. We're not going to combine them. We want things to the single x, or the same degree. This is the first degree. This is the second degree. It all depends on what power it is. So what other first degrees do we have? We've got one right here. That's a first degree. So now we have 3x minus 1x, which is a 2x. Now we can look at our positive 2x here. 2x squared, sorry. And we can combine that with a positive 1x squared. And if we do that, we've got 2 plus 1 is 3. And we're adding, because we got a positive answer, so it's adding. Alright, and then lastly, positive 4 and minus 1. Those are our constant terms, but we can still combine those. We've been doing that our whole lives. 4 minus 1 is 3. So, we could just put our answer as 2x plus 3x squared plus 3. But we'll see here, notice that the x squared terms and x terms are not like and cannot be combined by addition. There are other possible arrangements of collected terms, such as the following. This is what we got for an answer. But customarily, we arrange terms in descending order of exponents, so that the term with the largest exponent is on the left, and the constant term is on the right. Alright, and an expression written without a constant term is understood to have a 0 as a constant term. Because obviously if you add 0 to something, it's not going to change it. But to follow the customary way to do this, we put the highest degree on the left going down to the lowest degree. So 3x squared, that's a second degree, plus 2x, first degree, plus 3 with our constant. So that's how we would write it normally. Alright, so that's kind of our intro to this algebraic term stuff. And we'll talk more about it tomorrow.